The following coal has the following ultimate analysis by weight. So this is the percent mass of our components. A Stoker-fired boiler of 195,000 kilograms per hour steaming capacity uses this coal as fuel. So steaming capacity basically means that is our mass flow rate of our steam. Calculate the volume of air in cubic meters per hour. It's V dot in cubic meters per hour with air at 60 degrees F. 60 degrees Fahrenheit is equal to 15.6 degrees C. And 14.7 air pressure in kPa, that is simply 101.325. If the boiler efficiency is 70%, that is our E, and a factor of evaporation of 1.1. Okay, so how do we do this? From what we have, we can try to find the mass flow rate of air, if we know the mass flow rate of the fuel, as well as the actual air-fuel ratio. So, mass fuel rate of air, or rather mass flow rate of air, times is equal to the mass flow rate of fuel, times the actual air-fuel ratio. So first, we need to find the theoretical air-fuel ratio. So this is the formula. 1.5 C, 34.5 quantity H minus O over 8 minus 9.4, or rather 9.3 sulfur. And we simply use the values in our ultimate analysis. This one's 0.705. This one's 0.045. This one's 0.06. And our sulfur is 0.03. And we do get a value of 9.53 kilograms of air per kilograms of fuel. So to find our actual air-fuel ratio, we simply multiply our theoretical air-fuel ratio by 1.3. 1.3 is the empirical average, so this will do. 0.53 times 1.3, and that gives us 12.389 kilograms of air per kilogram of fuel as our air-fuel, actual air-fuel ratio. So we now have this. Next, we are given our factor of evaporation, and it has this formula. These are both in kilojoules per kilogram. So we have an Fe of 1.10. Simply substitute that. And we should be able to get our enthalpy difference. Okay, 2482.7 kilojoules per kilogram. We are also given our boiler efficiency of E, and it has this formula. All right, so E is 70% or 0.7. We are also given our mass flow rate of the steam right here. We already have our enthalpy difference, which is right here. We need to find our mass flow rate of the fuel. We need it here. And we still don't know our higher heating value. So to find our higher heating value, we can use Dulong's formula. It's a bit long, so let's just write that down. 33,820 C plus 144,212 multiplied by the hydrogen minus the oxygen over 8 plus 9,304 multiplied by the percent sulfur. Again, simply use our values up here, 0.705, 0.045, 0.06, finally 0.03. And QH should be around 29,530 kilograms, or rather kilojoules per kilogram. Now we have everything we need to find our mass flow rate of the fuel. Okay, so direct substitute, 70 mass flow rate of our steam times the enthalpy difference, 2482.7 over the mass flow rate of our fuel, that's what we're looking for, times the higher heating value of 29,530. And that should give us a mass flow rate of the fuel of 23,420.57 kilograms per hour. Okay, so now we have our mass flow rate of the fuel. Simply start putting the values in. Actually, let's go to the calculator and do it straight there. 23,420.57 times our actual air fuel ratio of 12.389. And that gives us 290,157.44 kilograms of air per hour. Now notice we are not done yet because we're looking for the volume flow rate of our air and not the mass flow rate. So for this, recall our favorite ideal gas law equation. Never get tired of this equation. PV is equal to mRT. So we already have our pressure right here of 101.325 kPa. Our volume flow rate, there should be a dot here. That's what we're looking for. We already have the mass flow rate of our air right up here, 9157.44. And of course, the gas constant of air is simply 0.287. What is this? Kilojoules per kilogram Kelvin. So that means we need to convert our temperature of 15.6 C into Kelvin by adding 273, and that should be in Kelvin. All others are in the right units, so let's put that in our calc. Shift solve. And we do get a volume flow rate of around 237,000 kilograms of air, or rather cubic meters of air per hour. And that is our final answer. If this helped, consider liking, subscribing, and supporting me on Patreon. Thanks and good luck.